Awesome. Well, everyone, this is our first series premiere of Akurate's Tech Talk. We're really excited about this opportunity to kind of share with you all some of the advantages of Akurate technology, and not just Akurate specifically. It's more of the science of why we did what we did in the market and how we're taking our technology now and really pushing to advance this industry into just a whole nother realm of what brings ROI to a contractor every day and brings absolutes in regards to installation and quality of installation. So with that, you probably see on the screen here, you got David Jacobs, our newest hire at Akurate Dynamics. Excited to have you on board, David.
Happy to be here.
Awesome. So I guess before we get started, Tech Talk, just real quick, what we're going to be doing is on our social media page, we have started to now ask for questions from contractors. We want them from you directly. So what we want to get out of this is, what questions do you have from the Akurate team? We'll have guest hosts on each week or each episode to kind of address a variety of things that have already been brought up, whether it's gear pump technology or hose technology, or just overall spray foam insights that we've kind of identified as an equipment manufacturer within the industry. So with that, we'll talk about how our technology works, the science behind it, and how it's changing the industry. So with that, before we get started, David, can you introduce yourself, kind of your background within the spray foam industry, and just overall, your experiences so far?
You bet. Yeah. So kind of started out, been in the business about 16 and a half, 17 years, somewhere in there. Started out doing metal roofing and single ply roofing. Transitioned into where I met the plural component was fleece back adhesives on TPO. Okay. Did that for years, moved out of that into working for a Graco distributor. The AC was a lot nicer.
Yeah.
It was a little bit less, but the AC and the less stress was pretty good. So went there, worked there for years, owned a service center, did that, did a couple startups. And now I've landed myself with Akurate Dynamics, top of the hill.
We're excited to have you on board, buddy. And you're located in Tulsa, Oklahoma, correct?
I'm located in Tulsa, Oklahoma, yes.
Awesome, awesome. So just real quick for me, my background, been in building materials for 10, 11 years now. Grew up as a kid working for my uncle's construction company in framing. Transitioned into low voltage wiring, audio, video, retro. And then as I kind of went after school, joined Firestone Building Products, and I was there for 7.5 years. And that's where I got the opportunity to evaluate businesses and industries. And we saw a lot of advantages in the spray foam industry. One, high growth, tremendous technology and what it means for a homeowner, and just overall, just a dynamic of what the value of spray foam is to a homeowner and customer contractors. From there, I was lucky enough to lead the acquisition team to buy Gaco Western, where I really got to cut my teeth in the spray foam industry and get heavily involved. And was fortunate enough that my predecessor was retiring, and I was able to work with the Gaco wall foam team for almost 2 years. So that's where I was fortunate enough to meet Trey Cook, and here I am on the Akurate team as well. So thank you all for joining on the Tech Talk today. As I said, we're taking questions that were submitted on our social media page on Facebook. And with that, we want to address one question here today on this episode. So with that, this question came from Ben Southern. He is with Inscoat Insulation and Coatings in Houston, Texas. With Inscoat since 2019, Inscoat is ready to tackle anything from the most complex and large-scale projects to the smallest repair jobs. They're located just down the street from us in Houston, and we're excited to be able to address that question today. So you can find more about them at inscoat.com. So with that, David, the question that Ben had presented to us was, how are clearances and slippage accounted for in a gear-driven proportioner system, and does trash or contaminants cause premature wear in the pump housing?
Good questions, Ben. It's two-part. I'll answer the second part first, and then we'll get into the first part. It's a little bit longer. The second part, trash in a system, it is a gear pump. We promote having clean systems. If there's any types of trash, we have fail safes, which are Y strainers and basket strainers in place. at Akurate, we run nitrogen blankets on our ISO sides. So if there is trash in the system, will it jam in the pump? Yeah, anything can jam in a pump. But we always promote a clean system, no matter what system it is. It has to be in order to operate. But I will tell you, if there happens to be crystals or something else that gets jammed in through here, it's not going to damage the gear pump. The gear pump is a steel gear pump, and there's only 2 moving parts. It's driven by a large electric motor. So it's pretty much maintenance for, it's not going to wear out over time. It's not like a traditional pump that has a lot of wear parts that you have to constantly maintain. A gear pump's not. Yeah, it's got probably 3 O-rings and 2 gears spinning, and that's it.
Okay, fair enough. So really, if anything were to get into this system that could potentially harm the gear pump, it would be no different than any other system where if something was that detrimental to it, it would break it down. But to your point, from a wear items perspective, it's a pretty simple process.
Yeah, it is.
Awesome.
So that's the first question, or that's the second question. I'll get to the answer for the first question, and that is slippage. So the way our gear pumps are working, we're not worried about slippage. We account for the flow and the volume and the pressure on outbound. We don't calculate the flow through the gear pump. As far as slippage goes, every pump has slippage. That's why on traditional 2-ball displacement pumps, we see wet cups where DSL bottle. That's basically taking the slippage back. So almost every proportioning unit on the market these days have a TSL area for slippage. We're not concerned to affect the slippage. I think that the slippage question is partially tied to questions about stall, and I think we've got a lot of questions about whether or not we can hold stall pressure. There's a document that was put out by a competitor that kind of pinned it against 2-ball displacements, against gear pumps and some of their weak links, and one of those was they don't hold stall pressure. And the truth about it is we don't have to hold stall pressure. We hold stall pressure after it leaves the gear pump. We hold pressure after that. But we're concerned with stall pressure. We're not concerned with seepage. All of the performance and the pressures and the stall pressures are held right afterwards with the check valve. And then after that, we flow through our flow meters. So that hopefully that answers that question for you, Ben.
Yeah, perfect. So when you talk about, like, I guess our flow meter technology, you know, we do, everything I've heard and everything I've seen and evaluated different flow meters in the market, we invested in the best. And it was really to kind of help control that process and the measurement of the process, creating that tighter resolution. It's like, do you want a 10 pixel TV or do you want a 1,000,000 pixel TV? One's going to look, you wouldn't know if your team scored a touchdown or not on a 10 pixel. So, I mean, can you maybe speak more to, you know, why we chose the flow meters we did and what that means for resolution, especially in a gear pump system? Because I think it relies on those types of measurements to really keep and guarantee for us on ratio foam.
Yeah, sure. Well, first, our accurate proportioners are dual motor, independent. We have independent motors, so they can kind of move the viscosity here and there. So how it works is we come out of our gear pumps, go into flow meters, and as it's going through our flow meters, we're recording every rapid fire communication with each other and the communication of the board. So what we're doing is we're pushing fluid through the flow meters. Now, viscosity is going to be different until it enters our hose, to where the performance and the technology really takes over in our hose. Going into the hose, we want to be pretty steady, and sometimes viscosities haven't quite gotten where they need to be. The centipoise on B side might be about 300 to 400 higher, which would indicate a higher pressure. So once we put it in there, the signals going from the flow meters on outbound to the pumps are communicating with each other. And in order to keep them exactly even, we might have the A side speed up a little bit to compensate for the B side, or vice versa. However, so our technology really bringing the fluid in, going it through the, pushing it through the flow meters, and then loading the high technology of our hose. So the meters are terrific points of communication for us. They're one of 3 that we use in order to ensure the system works really good with our technology.
Yeah, and I think you hit on another great point, and something we'll cover actually in the next episode with the question that came in is the hose technology and how we're kind of maintaining that basically that pressure balance all the way to the gun and managing viscosities and shear for that specifically. But yeah, I think you hit on it. I hope this is something for the industry and for the contractors and people that are posing the questions understand is this is a dynamic system. It is not a static system per se, where it's constantly at a certain amount. This will say, hey, listen, we see an issue at the gun, or we see something in regards to flow, and maybe it's the temperature of the material moving through the equipment. And and it's constantly going to adjust itself because this is a very dynamic, I keep using that word, but not one person has the same spraying conditions from Monday, Tuesday through Thursday, Friday kind of situation.
Sometimes conditions here in Oklahoma, for instance, here in Coweta, we've probably dropped to 10 degrees since this morning. So sometimes we need to make these changes, or the system needs to make these changes throughout the day. We did testing on some foams, and there were some foams that the A and the B had pretty relatively close viscosities between each other, and then we had a lot further off, about 600 CPS off of the ISO. So it's really, whenever we're running our fluid through the pumps and then through the flow meters, that's where the adjustment is being made. So we, depending on the equipment or the chemical that you're putting in the equipment, it may need to make adjustments on the fly. And that's what's great about our air pumps, is they can independently speed up and slow down to ensure that those flow meters are dead nuts.
Yeah, no, I completely agree. And like you said, I mean, even from 8:30 in the morning to 4 o'clock in the evening, I mean, this system is not, it's not like a one button press kind of thing, but it is going to work its hardest to ensure it's staying on ratio, or it's actually going to say you're off. There's something else, whether it's feed or whatever it may be, higher temperature or lower temperature material, cold material. All those things can contribute to system failures. This is going to at least tell you we're going to work to either achieve that on ratio spray or it's not. There's no alarms, no warnings. It is what it is. So no, I think that's great. I'm glad you were able to address some of the, at least the first question for this first Tech Talk. So first off, thanks for joining me today. We're excited to have you as part of the team. This has been great. And we're going to continue to keep doing these. I think we have 3 or 4 episodes already in the hopper. So we'll be launching those as quickly as we can do it. It is 2020, so who knows? We may be together. We may be doing it via Zoom. So thanks again for joining us, David. I appreciate it.
Thanks, Dusty.
Awesome. Thanks, guys. Have a great day.